We're going to do a review of what we've been learning the last week and a half with different operations in polynomials. And so now is the point where we need to keep things straight, and sometimes we make little mistakes remembering what do I do with these terms or numbers, do I add them or multiply them, that kind of thing. So let's just do a quick recap of what we've learned the last week and a half. So here is a problem. The polynomials are being added. Here's one polynomial. Here's another polynomial. They are being added. We're going to combine or add the like terms. Those are terms with the exact same ending. We're going to add the coefficients together and keep the variables the same as we do that. So let's identify like terms, terms with the same ending. Here I have an x to the third. Do we see any other x to the thirds? Nope. Here I have an x squared. Do we see any other x squareds? Yes, right here. So I'm going to put a symbol. Doesn't matter what symbol you make, but whatever symbol I put underneath the x squared, I'll do with the other x squared. So I realize that I got to combine those things in a little bit here. Here I see an x. That's supposed to be a heart. Do we see any other x's anywhere in here? Yes, right there. And then here I see a constant or a plain old number. And here's another constant or plain old number. So I can only combine things that have the same ending. So this 7x to the third does not have a buddy to combine with. It doesn't have another like term. So I just bring it down. It's still part of the answer, but there's no work that I have to do with that. Now when we go to the x squareds, the next lowest degree, I'll put them in descending order. I have negative 8x squared. I will combine that or add that with the 3x squared. So we add the coefficients, the numbers out in front that's being multiplied with it. So negative 8 plus 3 is negative 5. And then I attach the x squared. I don't do anything with the exponents. I keep them the same. So if I was adding x squareds, once I add the coefficients, I put x squared down. Next, I'll add the x's, 3x and negative 2x. Notice that's a negative. So 3 plus negative 2 is 1x. And so I'll write down plus 1, and I'll just bring the x along with it. However, you'll see if you were to check an answer on the bottom of a practice sheet or in the back of the book or a multiple choice test, they won't actually write down the 1. They'll just put an x there. Last but not least, add the constants. Negative 5 plus 11 is 6. That is combining like terms. Or adding polynomials together. Now, this polynomial, we are subtracting this polynomial from that polynomial. It's this polynomial minus this one. So these are being subtracted. Change the subtraction sign, this one right here, in between the polynomials to addition. And make every term in the second polynomial, the opposite. This is the same as adding the opposite, chop slash, or I kind of like this one the best, keep, switch, flip. We switch the minus sign here, or subtraction sign, to a positive, and then we flip everything in the other polynomial to the opposite. So a positive 3x squared becomes a negative 3x squared. A positive 2x, a negative 2x here becomes a positive 2x. A positive 11 becomes a negative 11. Now, people ask, well, what about over here? We keep everything in the first polynomial the same. It's just like if we were to take 5 minus negative 4. We keep the 5 the way it is, but we add the opposite over here with subtracting a negative. It's the same as adding a positive. So keep, switch, flip, add the opposite, but you have a lot of opposite marks to make here. Every term in the second polynomial gets switched to the opposite. Now it's just like adding polynomials or combining like terms. So here we go. I don't see any other 7x to the thirds. Then I see negative 8x squared and negative 3x squared. That's a negative 11x squared. So I added negative 8 and negative 3. Comes negative 11. I bring that ending down. Now I have 3x plus 2x. That's 5. And I bring that ending of x down. Last but not least, negative 5 plus negative 11 is negative 16. Bada bing, bada boom. Now these polynomials are being multiplied in the two examples above. Multiply every term in the first polynomial with every term in the second polynomial. When doing this, multiply the coefficients. If there are variables being multiplied together, add their exponents. When combining like terms, like what we just did up above in examples 1 and 2, we add the coefficients and don't change the variables. Up above, if we were adding x squareds, we kept them x squareds. Alrighty, so here we go. We're going to distribute this. Let's see if I can select all real quick. So we're going to do some distribution. I'm going to multiply this x with everything in the second polynomial. That means I am multiplying this x with 3 things over there. So x times x squared. When I'm multiplying variables together, I add their exponents. That's an x to the 1. So that becomes x to the 3rd because 1 plus 2, those exponents add to 3. X times negative 3x is negative 3x squared. X times 4 is 4x. Now, I'm done distributing that x to everything in the other polynomial. Now I will distribute a negative 2 through. So negative 2 there, there, and there. So I get negative 2x squared, positive 6x, and negative 8. And now we just combine like terms, just like what we were doing up above. There's an x to the 3rd. I don't see any others of those. There's a negative 3x squared and a negative 2x squared. We add the coefficients together and keep the endings the same. That's a negative 5x squared. Here we have a 4x and a 6x. Add the coefficients together, keep the ending the same. That's 10x. And then last but not least, we've got a number or a constant, negative 8. Bada bing, bada boom. Last one here. This 2x plus 5 quantity squared is the same as 2x plus 5 times itself. Or in other words, 2x plus 5 times 2x plus 5. So now we can do the same process here. Distribute the 2x to each of these two terms. You get 4x squared and 10x. And then distribute this 5 to both of the terms in the other polynomial. So we get another 10x plus 25. Final answer? Well, I can combine the 10x and the 10x. That adds to 20x. And then bring down the squared term and the constant. I'll put a box around this answer because I'm really excited about it. And there we are. That's a review of the 3 operations that we've done with polynomials. You'll get to divide polynomials in Algebra 2. Oh yeah.